Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we will start with a new topic, which is Picard's method of differentiation of one-dimensional equations. Picard's method for one-dimensional equations, we have Picard's method and Euler's method. Both of them are used for solving the differential equations, and we are going to do them one by one. In Euler's method also, there are two kinds of Euler's method. One is the normal Euler's method only, and the second one is modified Euler's method. Both of them are very useful from our exam point of view. Picard's method and Euler's method, and there is one more method which is Runge-Kutta method. That is also one of the important part of our exams, and these three questions are definitely asked in every year of ISS examinations from objective papers, or two, three, or maybe five. Minimum one question and maximum is five. Has been asked from these topic repeatedly since 10 years and more than that also. So let us begin with Picard's method. Picard's method is given as follows. Suppose we have a function of x and y. We have two variables x and y, and we have a function which contains both x and y. Or this can also be given as dy upon dx, anything of that. Both of them are equal. We at the starting point x naught is there and y naught is there, and we have to calculate. Suppose we'll calculate. This is an iterative method. What is an iterative method? When we do step by step increasing things. Suppose we are talking about loops in the computers. So loops are also iterative. It'll go for one step first, then on second step, then third step, and so on till the steps we have provided to make it go. That is iterative method. So Picard's method is also an iterative method. It will go step by step and reach the final destination in steps. Suppose we have n steps, and suppose we have to find yn. So first of all, it will find y1, then y2, and so on. It will reach to yn. And these y's are known as approximations. So first is first approximation. First approximation means we have to find y1. So the formula here is y1 x should be equal to y naught plus integration from x naught to x f x y dx. Here fxy is used, but we substitute because our range is from x naught to x, so we substitute as x as t. So instead of writing fxy, we'll write f of t into yt, because these are the variables. Y is dependent variable and x is independent variable. So y is dependent on x dt. This will write. Now the second approximation is like, if we have to find out y2x, then we will say that it will be y naught plus integration of x naught x. Here it is y naught t. So it will be function of x, which is again t, consider t here, and here we will take y1 of t, the above one, which we have calculated here. We will take this and dt. If I talk about the third approximation, this is very simpler method, and you can just do it in very small amount of time in the examination. You just need to know the concept and how to attempt the question, that we'll do. So if we have to calculate y3 of x, then it will be y naught plus integration from x naught to x f of t y 2t dt, and so on. If we calculate it like this, then we get our nth approximation, or which is also the general formula of this Picard's method. So in nth approximation, our formula will be y n plus 1 of x should be equal to y naught plus integration from x naught to x f t y. Here it is n plus 1, so here it should be minus 1. So n plus 1 minus 1 is n, y n t dt. This is your basic formula or the general formula for Picard's method, and this should be kept in mind. This one should be kept in mind while solving. If we put n equals to 1, n equals to 0, then it will be y0 1, y1 x, first approximation will come. Here it will become 0. If we put 1, then y2, second approximation will come. If we put it equal to 2, then this equation will come. So this is the general formula for Picard's method of approximation. Now let us attempt some PYQs, and I'll show you how to attempt them in your examination. So this is the question. This is the PYQ that has been taken. Let us solve this. I hope that all of you have seen the question. What is this? Y satisfies the initial problem. dy by dx. fxy have been given to you. fxy here is equal to 1 plus xy. And y2 is equals to 0. y2 means y naught has the value 0 when x naught is equals to 2. Then the initial points have been provided to us, and we have to find the approximation at x equals to 3. And they have asked use second approximation of Picard's method. So we'll use a second approximation of Picard's method. For I have told you earlier that it is an iterative method. So we cannot directly use second approximation. Firstly, we have to calculate first, then move on to second, and so on as required by the question. So we have to calculate for x equals to 3. We have been provided with x also. First we'll calculate first approximation. I'm doing it very slowly so that you all understand how to calculate it in the examination. First approximation method is that y1x should be equal to y naught plus integration from x naught to x fxy f t y naught t dt. Now we'll put the values here. y1x should be equal to y naught is 0 plus integration from x naught. X naught is 2. And in the above limit, we'll take it as x only. And fty. This is fty. Here in place of x, we'll put in place of x we'll put t, and in place of y we'll put the value of y naught. Y naught is nothing but 0 here. So we'll put 1 plus x 1 t into 0. Y naught t is equals to 0. So it will be nothing but equal to 1 and dt. So on solving this integration, we'll be getting x minus 2 as our first approximation. Then we'll move to second approximation. We have to calculate till second approximation only. And integration rules are very basic. I'm not telling you them. If you're not aware of them, then you can read your 12th class books. That will provide you with this. So second approximation has the formula y2x equals to y naught plus integration from x naught to x f t y1 t dt. Now here also y2x, I am writing here y2x equals to here y naught is equals to 0 plus integration from x naught. X naught we know that it is 2 till x. Let us keep it x till now. Fxt is 1 plus x y. But y1 should be taken. Y1 is x minus 2. So we'll take 1 plus t into t minus 2, replacing x with t's dt. This is nothing but integration of 1 plus t square minus 2t dt from 2 and x. If I integrate this, we'll get a formula as t plus t cube by 3 minus t square with the limits 2 and x. But they have told us to calculate at x equals to 3. So instead of x, let me write it 3. If we calculate it, we'll get our answer something of like 7 upon 3, which is approximately equal to 2.33 and so on, which is our option number B. You can solve it on your own. I'm not solving this integration problem. That is very basic for all of you. And as and when we practice Picard's method, our speed increases. This is how you attempt a question in the examination of Picard's method. Let us move to the second question. This is the second question, and here they have asked us the third approximation of initial value problem using Picard's method. They'll tell you which method is to use. So they have told us here also. I hope that all of you have noted the question. Let us now solve this one. So we have to calculate the third approximation. Fxy has been provided to us as x plus y, and y naught is equals to 1 when x naught is equals to 0. This will also have been provided. So let us say that first approximation is given by y1x. They have not tell us what should we take the values of x. So one step is lower from the previous one, but one step is higher because we have to calculate third approximation instead of second approximation. So this will be equal to y1x will be equal to y naught plus integration from x naught to x f t y naught t dt. Now placing the values here, y naught is 1 plus integration from x naught is 0 to x, f t y t is x plus y. X is replaced by t and y is replaced by y naught t. Y naught is 1 dt. And if I integrate it, I will be getting 1 plus t square by 2 plus t with the limits 0 and x. If I put the limits here 0 and x, then I will be getting x square by 2 plus x. This is our first approximation. If we calculate for second approximation, then the formula is y2x should be equal to y naught plus integration from x naught to x f t y1 t dt. If we solve this, y naught again is 1 plus integration x naught is 0 to x f t y1 t. So in place of x we'll write t, and in place of y we'll write the value of this y1 that we have gained from our first approximation, which will be 1 plus here again we'll replace x's with t's, t square by 2 plus t. So instead of writing plus t at the end, I will writing 2t dt. On solving this, we will be getting our answer as 1 plus 2t square will be t square plus t cube by 6 with the limits 0 and x. If I am directly putting the limit 0 and x here, I will be getting x square plus x plus x cube upon 6. This is my second approximation. And the last approximation, which is third approximation, is y3x should be equal to y naught plus integration from x naught to x f t y3 2t dt. Now y naught is again 1 plus x naught plus x naught and x. If we take it here also, we can solve the question. If we see here that this is not the answer of the question, as you can see, the last one is also not the answer of the question, as you can see, and this one is also not the answer. This will be the answer of the question, because as you can see, the number of digits are increasing as and when we are going to more approximation. In first there was x to raised to the power 2, and in second is there x raised to the power 3. So in third it should be x raised to the power 4, which is only in option number A. You can attempt that thing as well. But I'm just telling you how to save your time in the examinations. But here I'm telling you how to solve the question. So let us solve it first. X naught to x, integration x naught is 0 to x f t y2. X can be replaced by t, and y2t can be taken from here. If we take y2t from here, it will be replacing x by 2, 1 plus t square plus t. Instead of t, I am writing 2t here, plus t cube upon 6. So integration will be 1 plus 2t t square plus t cube upon 3 plus t raised to the 4 upon 24, with the limits 0 and x. Now if we put 0 x here in every place, we will be getting x square plus x cube by 3 plus x raised to the power 4 by 24, which matches exactly to our option number A, which I told you earlier as well. This is how we solve the question. Now moving forward to another type of question. Here we have to calculate the fourth iterate. So I hope that you have seen the question. Let us solve this as well. All of these we are doing are your PYQs, and this is how they ask you in the examination. Y4x is fourth iterate of the Picard's approximation, and they have given us fxy equal to 1 plus x square plus y square, and y naught is equals to 2, y x naught is equals to 1. Then what is y41? They have asked you what is the value of fourth iteration of Picard's method. Now if we see here y41, let us say that we find uh, y41. N has been given to us this, so we can write it as integration y naught plus integration of first of all we'll find first approximation. In first approximation we can find it like this: y1x should be equal to integration from uh, y naught plus integration from x naught till x. Here I am directly doing. Let us put the values directly. So y naught is 2 plus integration from x naught is 1 till x, 1 plus in place of x we'll write t square, and in place of y we'll write 4 dt. Okay. Now as you will see here, as I'm noticing that as and when we'll go down in this type of question, the fourth approximation formula will be y4t equals to 2 plus integration from 1 to x y4x. integration from 1 to x and f t y 3t, whatever we put here, the final, they have told us to calculate y4 1. So if we put here the final one, which is 1 to 1 f t y 3t dt, then we all know that if I integrate something, if I am integrating, suppose I have a function I and I am integrating, I have a function gx and I am integrating from a to a. The limits are a to a. Then always its answer is equals to 0 when the limits are same, because integration cannot attempt our point estimation. Here we are attempting a point estimation at a only, so it will always be equal to 0. Integration is for interval estimation. So here this whole term will be equal to 0. And we are only left with y41 equals to 2, which is our option number B, 2. This is how you attempt the question in the examination. You don't have to solve every question. They just trick you in solving questions. You have to notice it, that how they are asking the question and what can be applied. As soon as I saw that there is one in here, the last integration, it will always be one. So no matter if I derivate first approximation, second approximation, and third approximation, my final answer will be 2 only. So that's how you notice the questions in the examinations. Now moving forward to the last question of today's series, which is use Picard's method to compute y.2 correct up to 2 decimal places. Okay, so they have given us the function f x comma y should be equal to x minus y, and they have given us y naught is equals to 1 when x naught is equals to 0. Now we have to calculate y.2 up to 2 decimal places. They haven't said how much approximation do we have to apply, but they have told us that the answer should be up to 2 decimal places. So first of all, let us see if it comes in first approximation only. If I calculate first approximation, which will be y1 x should be equal to y naught, which is 1, plus integration from x naught 0 to x f t, t and y naught t. T is x is t and y naught t is 1 dt. If I solve it, I'll be getting 1 plus x square by 2 minus x. This will be the first approximation. So let us put our values here. If I put our values here, where x is equals to 0.2. If I put the values here, I'll be getting 1 plus 0.2 into 0.2 upon 2 minus 0.2, which will be exactly equal to 0.82 if you solve it. 1 minus 0.2 will be 0.8 and 0.2 into 0.2 upon 2 will be 0.002. So answer will be exactly 0.82. But we don't know anything after this 2. Our answer is coming exactly to 2 decimal places. So some of the people will take this answer correct, but this will not be correct, because the next number, if the next number is suppose 7, then this is not the approximate value. This should be 3. So this is not our answer. Let us calculate second approximation in this method only. In second approximation, y2x should be given as y naught, which is 1, plus integration from 0 to x, x minus y. X can be replaced by t and y is replaced by y1t. y1t or y1x has been calculated here. So I'll put this value 1 plus t square by 2 minus t. This plus t and minus t will get cancelled and this will be dt. And our answer will come out to be t cube by 3 minus t, with our ranges x and 0. and this will be equal to x cube by 3 minus x. Now if we put here uh, x equals to zero point 0.2, which has been asked in the question, y zero point 0.2, then our answer will be 0.2 cube upon 3 minus 0.2. 0.2 cube will be equal to 0.008 upon 3 minus zero point 0.2, which will approximately be equal to 0.843 and so on. And here if we see that if we take approximation, it will be something of it will be something like 0.837 and so on. So here if we take approximation up to 2 digit, then this is greater than 5 and this will increase by 1. So our value should be 0.84, which is our option number C. Many people, as soon as they find the first approximation, will correct the first one, but in the question they have clearly mentioned that we have to calculate till two decimal places, and two decimal places, for calculating till two decimal places we need to know what is at the third place of the decimal. So first answer, that is why first answer cannot be considered, and that is why we have to calculate the second approximation method. I hope that this question was clear with all of you. It was an important one, and I have taken almost all the important ones. Rest others are easier than them, and these were tricky ones. So I attempted to make you understand these kind of questions that they ask in the examinations. So that's all for Picard's method. And if you're facing any doubts in this topic, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.